Okay, hi, morning everyone. Sorry for the slight delay. I was in the middle of doing something just now. But okay, if you have your textbooks with you, please turn to page 251. Okay, page 251. I hope that you all have handed in the homework from yesterday. It's just two simple questions. But today we're going to go into this new subtopic, which is pretty heavy lah. Okay, and I'm kind of glad that we have two sessions today. So at least I can cover most of the subtopic lah. Okay. Now I want you all to be aware that there are some things in the textbook that I am skipping for now because it's hard for me to show it to you. I think sometimes I feel that you have to see it in order to understand what is this one lah. Because some things, if I explain kan, no matter how I explain also, it's difficult if you can't see it lah. Okay, and pictures are not enough lah. Okay, sometimes you have to experience it. Sometimes you have to do it yourself. So there are certain things that I will be skipping. Okay, but if if or when we go back to school, that will be the first thing that I want to do. Okay, which is to cover all the things that we missed. Okay, so that's the most important thing lah. All right, so today we're going to go into this new subtopic, which is called image formation, okay, by lenses. All right, so I hope you can see this. All right, so image formation by lenses is an extension of what we were doing previously. So previously we were talking about refraction. Okay, we started off this chapter by talking about refraction, and we say that when light travels from something that is less optically dense to more optically dense, it will be refracted. Okay, it will be bent. Okay, so that's basically how lenses work. So lenses, like for example, your specs, kanta, okay, lenses. So you know when light travels from the air into the lens, okay, of course in the lens the light will be bent. Okay, the light will be refracted lah. Okay, so the question that we need to ask is, how is the refraction of light, okay, in a lens? How does it look like? Okay, and to understand this, we have to know that there are two types of lenses. Okay, there is the lenses that look like this one, that look like your standard mirror, and then there's this lens that looks like yang macam kena kempis di tengah lah. Okay, so these are the two most common lenses that we see. Okay, and we call this the convex and the concave lens. Okay, now it's very easy to remember the cave sebab you know when you go to a cave, right, it's inside, there's a hole in there lah. So this is kind of, you know, if you're standing over here, then the cave will, sorry okay. So if you are standing over here, okay, then this is kind of like a cave. Okay, dia punya gua masuk di dalam sana lah. Okay, so that's what a concave lens looks like. Okay, so this is the first thing you need to know. There are two types of lenses, and one is called a convex lens, and the other one is called a concave lens. Now, both lenses, they refract light differently. Okay, that's why we have two different lenses lah. Okay, so for example, if I were to do an experiment like this, so I have a ray box over here in which there'll be three beams of light, okay, shining, and then you'll be headed towards this thing which is called the convex lens. This convex lens lah, sebab dia punya bentuk adalah seperti begini. Okay, so what will happen is, after these three light rays, when they pass inside the convex lens, they will be refracted. Okay, but they follow a certain rule. So the idea behind this subtopic is to understand the rules okay, that govern how light is refracted in the convex lens. And this is how it looks like. So after the light passes through, okay, the convex lens, all the lights will be refracted in such a way that they will meet at a certain spot. They will all somehow meet together at a certain spot. And then of course, because light travels in a straight line, so let's say for example this light over here kan, so it moves here, and then after it comes out, then it will be refracted this way, and it continues to go on straight lah. Okay, dia bukan sini lepas tu melompat bukan okay, it goes straight. So this one goes straight all the way down like this. Okay, so but the thing is this lah. Okay, this place where they all meet okay, this is what we call the converging point. Okay, converging point converge dalam bahasa Melayu is menumpu, titik tumpuan lah. Okay, so the first rule is this lah. In a convex lens, after light passes through the convex lens, when the light comes out of the convex lens, it will meet at a certain point. Okay, and dia punya point of course depends on the lens lah. Okay, we will learn this in a while. Okay, but this is the first thing. A convex lens is also known. Sorry. Oh, okay. So a convex lens, this is a convex lens. Okay, is also known as a converging lens. Because the function of the convex lens is to converge, is to tumpukan all the light rays, okay, to a certain point. Okay, and we call this converging point, we don't call this a converging point actually, we call this a focus point. Okay, because converging converging is very difficult to say, so we call this a focal point, not focus, a focal point, FOCAL point. Okay, so the point where all the light converges, okay, after passing through a convex lens is called a focal point. Okay, so this is the focal point. Okay, and because it's a convex lens, it's a converging lens, so all the light will be converged in one place. Semua cahaya itu akan tertumpu kepada focal point. Okay, so that's the convex lens. Okay, now when we look at the concave lens, okay, we find that instead of converging, dia adalah tersebar. Okay, dia bukan tertumpu, tetapi selepas dia melalui the lens, what happens is it is spread out. Okay, now the opposite of converge is called diverge. Diverge. Okay, so the concave lens, okay, is also known as the diverging lens. Okay, dalam bahasa Melayu, diverge is mencapah. So dia menumpu atau dia mencapah. Okay, and it's very easy for us to remember because the shape will tell us. If the shape is round like this, then it will focus. If the shape is like a cave, then it will diverge. Okay, it will mencapah. But even so okay, even so, now let's say if I were to draw a line, okay, to continue all this, we find that, okay, we find that all these lines, kalau saya sambungkan ke belakang okay, they actually diverge from a same point, which is still what we call a focal point. Cuma dia punya focal point ini adalah di belakang kantang, behind the lens. Okay, so a few key differences lah. If you look at the convex lens, the converging point or the focal point, okay, is the focal point is in front of the lens. So this is in front of the lens lah. Okay, so all the light will be converged in one place. Akan tertumpu pada focal point. Tetapi in a convex lens, okay, the light will diverge. Tetapi dia punya diverging pun akan berpusatkan, okay, it will still be centered on the focal point. Okay, cuma the focal point is in front of the lens, no longer behind the lens lah. Okay, in front of the lens. So this is the key difference between the concave lens and the convex lens. The function of the convex lens is to tumpukan the cahaya. The function of the concave lens is to spread out the light, is to diverge the light, okay, that passes through it. Of course, convex lens, concave lens have different functions lah. Okay, you will learn later which one is used for spectacles lah, contohnya. Okay, which one is used for magnifying glass, which one is used for microscope, telescope. And a lot of things in our world, actually we use lenses. Okay, and we don't always use convex or we don't always use concave. Ada setengah situasi di mana concave adalah lebih baik daripada convex. And some situations, convex is better than concave. But the first thing you need to know is this lah. Okay, the ciri-ciri, the characteristic of the convex, and the concave lens. Okay. Don't forget, as always, if you have any questions, please ask in the chat section. Because this is a live stream, so yeah, that's the only way you can ask. Okay, so if we were to draw it out, if we were to draw it out, this is how it would look like. We don't have to draw all 6 lights, okay? We just draw 2 enough. But coming from this, this slide over here, there are a couple of words that we need to talk about, okay, like this principal axis, axis of lens, what is this F, and what is this F besar, okay? So, in a converging lens, we call this focal point, okay, the F here is rail. Okay, now we're going to hear this word again and again, rail. Okay, now the refracted rays will converge. I will talk about rail. Rail bukan bermaksud dia adalah benar atau dia adalah true. Okay, there in light, when we talk about light, when we talk about lenses, this word rail, there is a meaning to it. Okay, and we will talk about it later. I just want to tell you that the focal point is rail, and the easiest way to know whether it is real or not is because it is in front of the lens. Okay, no, behind the lens. Sorry, di belakang kanta. Okay, so anything that is belakang kata, this side now is real. Okay, and then this side is the opposite of real, which I will talk about later. Okay, now F is positive. Okay, this one we will talk about this in the next subtopic, but now it's just to let you all know lah. Okay, now in the concave lens, okay, the same few things over there, apa itu axis of lens, principal axis, and as I said before, after the light comes through here, it will actually diverge. Okay, so this part over here is yang kita sambung sendiri untuk mencari tempat dia menumpu. Okay, this is actually not shown in the design. We have to figure this out ourselves. But actually light travels like this, and then dia akan terus tercapah macam ni. Travel from here, then they will capah this way. Okay, it doesn't come back here. This one is kita sambung sendiri. So this is called a diverging lens, and we call this the opposite of real. It's called virtual. Okay, so this is the interesting thing lah. Okay, the interesting thing is if the focal point is here, okay, then this is real. But if the focal point, tempat di mana the cahaya ditertumpu is in front of the lens, okay, we call this focal point a virtual focal point. Okay, virtual focal point. Because okay, let me see. Okay, because remember this situation. Okay, we cannot see the I cannot see whether this one is. Dia tidak jelas. What we can do is we can use a ruler and we can draw a straight line over here. Try to join all this one together until we find this place where all the points meet. Sorry. Here. So it meets somewhere over here lah. Okay, it is not seen. Dia bukan macam ni tau. It's not like this. This is very obvious that this is the focal point. Okay, you can see. You don't even have to draw anything extra. That's why we call this focal point a real focal point because it can be seen very easily. Okay, manakala in this case we call this a virtual focal point because you cannot see it until you draw the lines. Okay, until you yourself kena buat satu extra step lah to figure out where is the focal point. So that's why we call this a virtual focal point. Okay, because there is some extra work involved to determine the focal point. Okay, so this is 2 words that you're going to hear a lot. Real, virtual, real, virtual. You're going to hear this word a lot. Okay, and it is part of the assignment that I'm going to give you much later lah. Okay, so please get used to these words. Real is anything that is formed behind the lens. I always say in front. Everything that is formed behind the lens is real. Anything that is formed in front of the lens itself, okay, is virtual. Very important. Of course, that's not the real definition. The real definition I will tell you later lah. Okay, so let me see. Okay, so the refracted rays diverge and the F over here is negative. Okay, this F kecil okay, kenapa kalau dia behind the lens is positive, and then in front of the lens is negative. I will explain this to you in the next subtopic. Okay, but for now, let's just take it as it is first. Okay, so let's talk about these words that we saw just now. Okay, now what this is something we call this. Okay, we call this a, oh dear. Okay, we call this a ray diagram. Okay, apa ini? Sorry. Okay, we call this a ray diagram. Okay, so the ray diagram shows the light that comes from an object and then goes, how does an image form? So we use this thing called a ray diagram. Now, a ray diagram is best experienced if you have the worksheet. Okay, but the only problem now is a lot of you don't have printers, and it's going to be a little bit difficult. Okay, so when we go back to school, one of the things that I want to do is to teach you how to draw the ray diagram. Okay, but that is much later. But we still need to understand how a ray diagram works. Okay, so the first thing you need to know is this O. Okay, O is called the optical center. Okay, the optical center is the point at the center of the lens, right at the center over here. Now, light rays that pass through the optical center is not refracted. Anything that passes through the optical center, which is right over here, okay, or here, is not refracted. That's the first thing you need to know. Secondly, the principal axis. This line is called the principal axis. It is a straight line that runs through the optical center and the center of curvature. Okay, so this line that runs through the optical center is called the principal axis. Okay, thirdly, the axis of the lens is this vertical line. Okay, it is a line that is perpendicular to the principal axis. Basically, dia punya paksi lah. Okay, ini paksi utama, ini paksi kanta. Okay, fourthly, focal point. So the focal point is a point that is located on the principal axis, and different lenses have different focal points. Okay, which we will talk about in the next topic. But you should know that different lenses have different focal points. Okay, so the focal point, you're not supposed to remember okay, usually you're told that okay, this lens has how much is the focal point. Okay, but it is a very important this one. Okay, now f small is called a focal length. Okay, the focal length is the distance between O, the optical center, and the focal point. Okay, now f can work both ways. Okay, but for convex lens, the f is on the real side, and for concave lens, the f is on the virtual side. Jarak di antara the O and tempat di mana cahaya menumpu, that is the focal length. Okay, in the case of the diverging lens, the distance between O and the place where the light focuses on the same place where the light diverges. This is called the focal length. Okay, now object distance is the distance between the object. Okay, this can be an arrow, this can be a letter A, B, C, okay, anything lah. Okay, the distance between the object and the optical center is called the object distance. Okay, manakala the image distance is the distance between the axis of the lens and the optical center and the image. Okay, actually very easy to understand. If the object is here, this is the object distance. Everything is in relation to this optical center. Paling penting is this optical center. The distance between the optical center and blah is this. So these three things, U, F, and V, semua adalah berkaitan dengan optical center. Okay. Distance between the place where the light converges is focal length. Distance between O and the image is image distance. Distance between O and the object is the object distance. Okay, so these are terms that we always use when we talk about optics. Okay, when we talk about lenses, when we talk about light. Okay, now these are a few characteristics of images that are formed by lenses. The first characteristic is if the light passes through the optical center, the light doesn't get refracted. So same way, if let's say the light passes through like this, right, it will just go through like this straight. If the light goes through here, it goes straight. So this is the number one rule that you have to remember. Okay, light that passes through the optical center, okay, whether in a convex or concave lens, it just goes straight through it. Okay, that's characteristic number one. Characteristic number two, if you have a light that is parallel, apa ini? Sorry, parallel. Okay, to the axis, the principal axis. Okay, selepas dia melalui this garisan, what is this line? This is called the lens axis. Okay, after it passes through the lens axis, it will be refracted towards the focal point. Okay, in the same way, for the concave lens, it will be refracted after passing through the axis of the lens. It will be refracted, tetapi mencapar dan dia adalah tumpuannya adalah pada F in front of the lens. Okay, so this is the second characteristic. Third characteristic is if you have a light that it passes through the F, when it passes, after it hits the axis of the lens, it will be parallel. In the same way, like that. Okay, if you have a light that is macam seolah-olah dia mau pergi sini, after it passes through the principal axis, after it passes through the axis of the lens, okay, it will be parallel. Okay, so like this. So this is for example, this is a convex lens lah. Okay, can you see this? Okay, so this is a convex lens. Now, so the second rule says that after this is the principal axis, this is the axis of the lens lah. Okay, so after the light, if the light is parallel to the principal axis, after it passes through the axis of the lens, it will be focused, it will be refracted towards the focal point. Okay, that's the third one now. The first one that I said just now, any light that passes through the optical, this one is not refracted. It will just be in one straight line like this. Okay, parallel with the principal axis, converge to point F. This one is light will pass through the optical center, will not be refracted. This one is pass through the focal point. Once it passes through the axis of the lens, it will be parallel. Okay, so the three rules, okay, these are three very important rules. Three rules that govern how you draw ray diagram. Okay, the first rule is parallel focal point. Second rule is optical center. Dia tidak kena refract. The third one is focal point, then parallel. Okay, you only need to draw three rays in order to determine where the image is, which we will talk about in our class later lah. But the same thing happens, okay, for concave lens. Okay, this is parallel to the principal axis, okay, and since it is parallel, after it passes through, it will diverge. But it will diverge dengan tertumpu pada the focal point over here. So parallel with the principal axis will diverge as it comes from the focal point in front of the lens. Okay, in front of the lens. Now, same thing, light that passes through the optical center will not be refracted. It will still go straight. Okay, same thing like this. Light that passes through the optical center will be over here. Okay, so the question is, apa ini? Why is this cahaya over here? Okay, now this is what we studied yesterday. This is a little bit of reflection. Okay, this is inevitable lah. Okay, because ini masih satu surface, some of the light will still be reflected. But most of the light will be refracted. Although in this case, there is no refraction lah, sebab dia melalui optical center. Okay, light that passes through the optical center will go straight without refracted. Okay, so actually, if we are in school, this is the thing that we want to do. We want to use this ray box and then go and play around in the lens lah. Okay, but let's hope that we go back to school soon so that you all can play with this lah. Okay, all right. So, for our class today, okay, before we meet later, okay, so later we're meeting at 11:30, right? I want you to make sure that you have this in mind. Okay, because after this, we're going to be doing an activity, a virtual activity. That's why we need to use Google Meet to determine all these things. Okay, so take some time. Okay, now it's only 9:40 here. So take some time. I want you to remember the three rules of light that passes through the lens. Okay, it is the same. Dia sama ni, whether it is concave or convex, it is the same. The only difference is for convex lens, for concave and convex lens, after light passes through concave, it will diverge. But diverge, the focal point is in front of the lens. Kalau convex, okay, after light passes through the axis of the lens, it will converge towards the F. Okay, and that's the basic difference between the two. Everything else is the same. Okay, so take some time, go and read through your textbook, okay, and remember these three rules. Because in the next lesson, we will be taking a look at these rules and we will see how it is used to determine the image. Okay, which is what I want to do later lah. Okay, I'm purposely dividing this into two different classes because this next part, the next part is a little bit more complicated lah. Okay, I want you to know how is it that if we use any lens, for example, the lens of the specs on your face, okay, how is the image formed on our retina and everything? How is the rules? How are these three rules used? Okay, to determine where the image is, what kind of image is it? All this we will talk about later. So for now, okay, use this time, about 20 more minutes you have, okay, go through these three very important rules. Okay, and then I will see you for your class later. Okay, see you.